In this video, we are going to go over the problems for problem 1.1. These are the ACE problems I assigned for homework on Thursday night, February 27th. So, in this problem where you have Billy who's going to the fabric store, she has on her $16.95 and she wants to buy 3 items. The first one is fabric for $8.69, the second is glue for $1.95, and the last one is craft paper for $4.29. So our question is, how much does she have left after she pays for the items? So to figure this out, the first thing we have to do is find out what the total cost of the items was. So to do that, we're going to add the price of the 3 items. So what we have here is $8.69 plus $1.95 and $4.29. Now I know you all know this, even though we haven't really talked yet about adding or subtracting decimals, but when we do add or subtract decimals, the most important thing is that we line the decimals out. And when we do that, really we can go ahead and just bring the decimal down, because that's where it's going to be within the answer. So now it just becomes an addition problem. So let's do this. 9 and 9 is 18, plus 5 is 23. We carry the 2. 2 and 6 is 8, plus 9 is 17, plus 2 is 19. There's our decimal. We're carrying a 1. This is 9, 10, and 4 is 14. So what we found out is that she spent $14.93. Now, if she walked into the store at $16.95, she then subtracted that $14.93 from what she had. So that's what we have to do to find out what she has left. So this is step 1, and step 2 will be to subtract. So we're going to take that original amount of $16.95, and we're going to subtract the cost of the items, which was $14.93. Again, we're lining the decimals up. We can bring it right down. 5 minus 3 is 2. 9 minus 9 is 0. 6 minus 4 is 2. And of course, 1 minus 1 is 0. So, our final answer is, to the question, how much does she have left after she pays for the items? Billy has $2.02 left. Has $2.02 left. And that's number 1. Alright, let's move on to number 2. In this case, so it says Greg's home is 1.8 miles from his school. So over here we have his house, and here's a school. And this line all the way across here represents the 1.8 miles from his house to the school. Okay, today Greg wants to stop at the store after school. Right now he's 36 hundredths of a mile away from the school. So here's Greg right here, and he's walking from school to the music store. And this line right here represents 36 hundredths of a mile. So that's how far he's walked so far. So the first question is, how far is the music store from Greg's school? So if we know that the music store is right in the middle of his house and the school, well, we would know that. I'm going to kind of put a little line right here to represent the exact middle. So if the music store is right in the middle, then we know half the distance is on this side and the other half is on this side. So to find out how far the music store is from Greg's school, we're just going to divide. We're going to take the total distance, which is 1.8 miles, and we're going to divide that by 2. Now, of course, as we move forward, we're going to go into specifically how we divide with decimals. As of right now, you would have been doing it with a calculator. So when I do this, I'm going to get 9/10 of a mile. So Greg's school is 9/10 of a mile from the music store. So the answer right here is 9/10 of a mile. Okay, so let's just draw a little line here to show that this represents from the school to the music store. It represents 9/10 of a mile. And just for good measure, if that's the case, then we know from the music store to his house also represents 9/10 of a mile. And together, we have 1.8 miles. Okay. Moving on to number 2. It says, how much farther does Greg need to walk to get to the store? So if the total distance from the school to the music store is 9/10 of a mile, and he's already walked 36/100 of a mile, we're going to go ahead and subtract that. Much the same thing if I gave you a question that said that so-and-so has to walk, let's say Greg had to walk 10 miles, and he's already walked 3 miles, how many more does he have to go? So I take my 10, I subtract what he's walked, while he still has 7 miles to go. So same thing here. Again, if he has to walk 9/10 of a mile, and he's already went 36/100 of a mile, I just subtract. So I go ahead and, much like adding, or exactly like adding, I have to add my decimals. I have to line them up. So right here I have 9/10 minus 36/100. You guys should probably know that I have to add something there. I have to put a 0 there so I can subtract the 6 from it. Let's bring our decimal down, and now it's just a matter of subtraction. So that becomes an 8. 10 minus 6 is 4. 8 minus 3 is 5. And of course 0 minus 0 is 0. So there's my answer. So how much farther does Greg have to walk to get to the store? He has to walk 54/100 of a mile. Okay. On the number 3. On C, I'm sorry. So it says, how many miles does he have left to walk home? Alright, so I'm going to tackle this just the way I tackled B. So I know that eventually he's going to walk all the way home. So when it comes down to it, he'll have walked from school to the store to home, which is 1.8 miles. So if he's already done 36/100 of a mile, I subtract that from the total distance. Again, the total distance being this 1.8 miles. So I do 1.8 minus 36/100. And once again, I need to put a 0 up here to subtract the 6 from it. And let's bring our decimal down. It's just a matter of subtraction now. So let's borrow. 10 minus 6 is 4. 7 minus 3 is 4. And 1 minus 0 is 1. So he still has to walk 1.44 miles. And that's number 2. Alright, let's move on to number 3. So we have a local farm grows strawberries, blueberries, and raspberries. Customers can pick their own fruit at the farm for $2.95 per pound. So the first question says, the Payne family picks 10.5 pounds of raspberries. How much do they have to pay? So, we know 2 things. Number 1, they picked 10.5 pounds of raspberries. And the next thing we know is that they're being charged $2.95 per pound. Alright, so what we're going to have to do here is multiply these numbers together to go ahead and find our answer. Now, we are going to spend some time going through how to multiply decimals. So again, this isn't something I expect you to know how to do right now, and that's fine if you're using a calculator. So when I go ahead and multiply these two together, 10.5 times 2.95 or $2.95, it is going to equal, you'll get this, 30.6 5.975. Now, when we look at that in terms of dollars and cents, we only have 2 spaces for cents. So we have to go ahead and use this number to the right, the 5, and tell us whether or not we round that 7 up or we keep it the same, and you probably already know that I'm going to round it up. So the answer to question A, how much do they have to pay? Well, they have to pay $30.98 for all those raspberries. For the next problem, a week later they come back, they get 6 3/4 pounds of blueberries, and they also get 5.2 pounds. They get 5.2 pounds of strawberries. So, and of course, the question is how much do they have to pay? Of course, they're still using this right here, $2.95 per pound. So we have to find out how many pounds they got all together. So that's for A, and this is for B. So the first thing I want to do is add these together. So when I add them, again, line my decimals up, bring my decimal down. 5 plus 0 is 5, 7 plus 2 is 9, and 6 plus 5 is 11. So I know they're getting 11.95 pounds. And again, we go back to this. For every pound, they have to pay $2.95. So I'm going to take this 11.95 and I'm going to multiply that by the price per pound, which is $2.95. And when I do that, either on paper and pencil or a calculator, I am going to get 35.2525. Now again, we're talking about dollars and cents, so I'll have 2 spaces here. I look to the right, this number is less than 5, so I'm going to keep this 5 the same. So the final answer for B is that it cost them $35.25 for all of their blueberries and strawberries. So there's number 3. Alright, for number 4. So the question reads, the drink dispenser at a fast food restaurant holds 250 liters of lemonade. How many 6/10 of a liter drinks can be dispensed before a refill is needed? So, what I'm going to do is actually I'm going to ask you a different question. Let's just pretend we have one of these, a big drink dispenser, and it looks something like this. So it's really big and it dispenses your favorite drink. And let's just say it was 10 gallons. Now, if it's 10 gallons and you had, let's pretend this cup right here, if you know it looks kind of small, let's pretend it's a 2-gallon cup. Alright, so if you had a 10-gallon dispenser and each one of your cups or big jugs is 2 gallons, how many of these can you fill up? And I'm quite certain that every one of you would be able to tell me the answer to be 5. I would be able to fill up 5 of these. Alright? And I took that by taking the the total amount that I have and dividing it by the size of each serving. So that's no different than this problem right here. So the amount that I have is 250 liters. And the size of each serving is 6/10 of a liter. So this means 250 divided by 6/10. And when I do that, I am going to get this. So I'm going to get 416 and about 2/3. So if the question is how many 6/10 of a liter drinks can I dispense, well, I can only do 416 total ones, because the 417th one is only going to be about 2/3 of one. So the answer to this question is 416 drinks can be dispensed. And that's number 4. All right, so let's look at number 5. So it says Chris, Kiona, Seiko, and Dwayne each run 100 meters in a relay race. Chris runs his part of the race in 12.35 seconds, Kiona takes 13.12 seconds, and Seiko takes 11.9 seconds. With all of that being said, question A asks us, the team wants to break the school record of 48.92 seconds. How fast will Dwayne have to run? So the first thing we have to do is we have to figure out the parts of the 3 runners so far. So we know that Chris ran his part in 12.35 seconds. We know that Kiona ran her part in 13.12 seconds. And Seiko ran hers in 11.91 seconds. So far, the total time, I'm going to add these together, is going to be... Sorry, so remember to line our decimals up, bring the decimal right down. So 37 and 38 hundredths. 37.38 seconds. Okay, so now if they're trying to get to beat this, to be less than that, here's what we have to do. Here's one way we can look at it. If that's the total, and I don't want to pass this, what I'm going to do is I'm going to go ahead and subtract the total the kids have ran so far from the time they want to beat. So if I do that, I'm going to again line the decimals up, bring the decimal right down, and let's just go ahead and subtract. So we have to borrow. 12 minus 8 is 4, 8 minus 3 is 5, 8 minus 7 is 1, and 4 minus 3 is 1. So we come up with 11.54 seconds. Now let's just say that he ran this race, his part of the race, in 11.54 seconds. Now, don't forget what this number represents. This number represents the time that the kids, his 3 other team members, have run. So I'm going to write it right over here. So 37.38. And let's go ahead and add his time. So 11.54. Now when I add these together, you might have already picked up what's going to happen, but 8 plus 4 is 12. We carry the 1. That gives us 9. Bring our decimal down. That gives us 8 and 4. So if he runs at exactly 11.54 seconds, they're actually going to tie the school record. So back to the question, it says, how fast will Dwayne have to run? He's going to have to run the race in less than 11.54 seconds. And if he runs it in less than 11.54 seconds, then the team will break the school record. Alright, that's A. Let me get some of this stuff out of the way here. So moving on to B. So B asks us, it says the team sets a new record of 47.65 seconds for the relay race. On average, how many meters did the team members run per second? So a lot of people in class had a hard time with this question. So I'm going to ask an easier question. Let's just say that somebody drove in a car 300 miles. And they drove that 300 miles in 4 hours. So they drove it in 4 hours. So my question is, how many miles per hour were they going? Now, I'm quite certain that you can all answer this question, because what you would do is you'd say 300 divided by 4. I know all of you would do that, and you would get 75. So the person was traveling at 75 miles per hour. So what I did to find miles per hour is I took the distance we traveled and divided it by the time that it took us to get there. That's going to be no different than meters per second. I'm going to take the distance that the team traveled, and the team traveled 400 meters, and I'm going to divide that by the time it took them. So 47.65 seconds. Alright, so I'm going to take this and divide it by that to get my answer. And when I do that, I am going to get about, I think we rounded it to 8.39 meters per second. And again, we're going to talk specifically in the next week or so about how to actually do that division on paper and pencil. So, but that's the answer for B. For C, on average, how long did it take each member to run their 100 meters? You had a question exactly like this a couple days before. But essentially, we have the team ran a total of 400 meters. So, if they want to know, on average, how long did it take each person to run their section of it? So again, we have 4 sections, 4 runners. So essentially what I'm doing is I'm taking this 400 meters and I'm dividing it by 4. And when I do that, that shows me what I'm breaking it out into. I'm breaking it out into 100 meter increments. So what I have to then do now is I have to take the time that the students ran in, and that is 47.65 seconds. And I have to divide that by 4 as well. So when I do that, I'm going to go ahead and just sort of do it up here. I'm going to get 47.65 divided by 4. I'm going to bring my decimal right up. 4 goes into 4 one time. It goes into 7 one time. There's 3 left over. 4 goes into 36 9 times with none left over. 4 goes into 5 one time. And there's some left over, but I'm going to kind of just stop right there. And I'm going to say that it took them, on average, about 11.91 seconds. Or we could say about 11.9 seconds. So on average, how long did it take each team member to run 100 meters? It took them about 11.9 seconds. And we are going to, again, go through all of this, and we're going to talk about rounding and so on and so forth. Now, before we move on to the next problem, I want to ask you all a question. And the question is this: could I have set up a proportion to solve this question? And your answer should be yes. So, if we know that all of the students together, they ran 47.65 in 47.65 seconds, they ran 400 meters. Alright, so this number up here represents the seconds, and this down here represents the meters. So the question is, how many seconds on average did they run 100 meters? So to do this, I'm going to go ahead and cross multiply, and I would get 4,765 equals 400x, And then you should all know that by now I'm going to divide both sides by 400 to isolate the variable. And I would get x equals, and I should get the same answer when I went ahead and did the operations here. All right, so I'll get about 11.9 seconds. That's number 5. That's a problem here, guys. So it says here, number 6 says every year students at Memorial High School volunteer to clean up local highway roadsides. Each club at the school cleans a section of the highway. A club member uses a trundle wheel to measure out the student's part of the highway. A trundle wheel can measure distances in thousandths of a mile. With all that being said, on to question A. Carmela signs up to clean 1.5 miles for the cross-country team. After she cleans a quarter of a mile, it starts to rain. How much does she have left to clean? So if we look at this question and say, well, she signed up to go ahead and clean up 1.5 miles. She started doing some work, and she managed to go ahead and do a quarter of a mile. So what I'm going to do is I'm going to go ahead and now subtract that from what I agreed to do, because I've already done it. So again, line the decimals up, bring my decimal down. I have to put a 0 up there to subtract the 5 from it. And now it's just a matter of doing some subtraction. 10 minus 5 is 5, 4 minus 2 is 2, and 1 minus 0 is 0. Nope, 1 minus 0 is 1. So how much does she still have left to clean? She has to clean 1.25 miles. Alright, for B, it says Richard cleans a quarter of a mile for the course. He cleans another 375 thousandths of a mile for the math club. How much does Richard clean altogether? When you hear that word altogether, generally speaking, you're going to be adding. So I'm going to take that quarter mile that he cleaned, and I'm going to add it to the 3/8 of a mile that he cleaned. And decimals lined up. Bring the decimal down. Put a 0 there. Make it look nice. 5 plus 0 is 5. 5 plus 7 is 12. Carry the 1. This gives me 6. And that gives me 0. So the answer to B is that he has cleaned so far 625 thousandths of a mile. Or you could say that's 5/8 of a mile. For C, it says VJ, a member of the chess club, cleans 287 thousandths of a mile. He later cleans another 200ths of a mile. How much does he clean altogether? Again, the word altogether is in there. That's a lot of togethers, and we're going to add them together. There's another together. So we add them, and we're going to get, let's go ahead and put a 0 there. 7 plus 0 is 0. 8 plus 2 is 10. Carry the 1, and that gives us 307 thousandths. Alright, and last but not least, D. Janet, she cleans 5 thousandths of a mile past her goal of 85 hundredths of a mile. For the debate team, she claims she cleaned 9/10ths of a mile. Is she correct? So if she originally agreed to clean 85 hundredths of a mile, but she cleaned it an extra 5 thousandths of a mile, let's add that to what she originally cleaned. So we're going to get this. Decimals lined up, bring it down. We have 5, 5, 8, 0. So she cleaned 855 thousandths of a mile, which is less than 9/10ths of a mile. Now it's really close to 9/10ths of a mile, but it's not quite there. And that finishes up the questions for ACE problems for 1.1.